right, so our last section tonight is 7.4, and it's on adding and subtracting rational expressions. Now, if you'll remember from 5th, 6th grade, it's probably when you did this, when you started doing it. In order to add two fractions together, they had to have like denominators. So this is what most students, even 12th grade students that I get, they still cannot make equivalent fractions so that they can add them together. So I would venture to say 40% of you probably still have trouble with it because it is just a concept that is very difficult to grasp. So I'm going to do my very best to fill in the gaps that you might have. If I don't, I apologize, and maybe we can find some extra resources for you. But hopefully tonight it'll just like go, oh, that's what it was. Okay. So to add fractions, they have to have the same denominator. And I think when you were really first learning it, what I remember learning it is they would give us a picture of like a pie. And they would say, you have 2 out of 5 pieces left of this pie, and it was 2/5. And you have another piece of pie that was cut in 8 pieces, and you have 3 out of 8 pieces of pie left here, then how much pie do you really have? And so you had to add 2/5 plus 3/8. And so you had to learn to get, they had to have common denominators to be able to say that you had this much of the pie left. Fractions are really important in our real life, much more than we like to act like they are. So, we deal with fractions with money all the time. If I lose half a pound, I like that way better than none. So, or 3.2 instead of 3, okay? So, decimals are fractions too. 2/10, 0.2 is 2/10, right? That's a fifth, okay? So, very important that you are able to understand fractions for all kinds of reasons other than just being able to pass this class. So, if the denominators are like, then you can add and subtract the fractions by adding or subtracting the numerators and keeping the like denominator. Okay, so there is a general rule at the top that says if you have A over B plus C over B, that equals A plus C over B. So it's different from multiplication, because with multiplication, you multiply the denominator times the denominator, and they don't have to be alike. But with addition, they do, because the whole concept of adding is that you are able to say, I have this much of one thing. Okay? So I have about 40 pencils here, but if there were some pens in here, I couldn't say I had 41 pencils, because I have 40 pencils plus one pen. So you can't add things that aren't like. So that's the whole concept behind this. The same thing is true for subtraction. If you have A over B minus C over B, that is A minus C over B. We'll start with some easy problems from 4th grade, okay? If I have 1/9 plus 5/9, you cannot cross-reduce within an addition problem, okay? That is only for multiplication of fractions. Not that I would here, but I just don't want you to think that you can. You follow these two rules. So it's 1 plus 5 all over 9, which is 6/9. And then, of course, you should reduce the fraction if it will reduce. 3 goes into both of those 2/3 times. Okay? So if I had 1/9 of the pie left and 5/9 of the pie left, then I really have 2/3 of a pie left. Okay? Subtraction, same way. If I have 17/12 minus 5/12. Now, if you remember, 17/12 is called an improper fraction because the numerator is larger than the denominator. In algebra, we like improper fractions, okay? We use them. We don't change them to mixed numbers anymore. Very seldom do you do that. The higher in math you go, the less mixed numbers you see, okay? You use mixed numbers mostly in cooking, like recipes, or if you're measuring things like that, you know, if you 6.5 feet, that sort of thing. All right, so 17/12 minus 5/12 is 12/12, which reduces to 1. That's a ratio of 1, right? Okay, so we're going to use these two problems that we just did, which are baby problems, to lead us into work with rational expressions, okay? Here we go. 6x, let me change colors. 6x over 3x minus 1 plus 5x over 3x minus 1. The denominators are the same, so that means you keep the denominator of 3x minus 1 and you add the numerators. 6x plus 5x is 11x over 3x minus 1. Can I cancel the x's? No, because this one is in a quantity, isn't it? Okay? It has something multiplied by it and subtracted from it. You can't cancel it unless it's just in factored form. Oh, I love this problem. This is a good one. X squared over x minus 4 minus x plus 12 over x minus 4. This is a non-math lover's nightmare because it has a minus sign, and in the numerator behind the minus sign are two terms. So you have to remember to apply this minus sign to both of those terms. You have to subtract the entire quantity that's behind it, not just one of them, but both of them. That's where it becomes a nightmare, okay? So, because you'll be just like one little sign off, but it'll mess your whole problem up. So let's rewrite it now. The denominators are the same, so that's good. So I'm going to have in my numerator x squared minus x minus 12. Now, you should be far enough along in your factoring techniques that you think that might factor, and one of the factors might be x minus 4, okay? When you look at a trinomial, you should always think, does it factor? Because a lot of times it does, if it's in this form, x squared, x to the first constant. Okay, so will it factor? I'm inclined to think it will. X and x. Factors of negative 12 that add to be negative 1 are negative 4 and positive 3, which is exactly what I thought, isn't it? I thought one of them was going to be minus 4. And this is so much fun because that big problem became just x plus 3. Okay, so y'all know we're moving into ones that don't have like denominators, right? Like you saw it coming. Here we go. We're going to do easy problem from elementary school or middle school, whenever you did them, I can't remember. First, just to kind of warm our brains up into what we're moving into. So if I gave you 8/15, does anybody have a question on this one, by the way? Any questions before I move on? Okay. 8/15 plus 3/10. I did not mean to make one fraction smaller than the other one. It's the angle, of course. But I can't add these together. Don't say it's 11/25. That's not right, is it? That's wrong. Okay, so they have to have a common denominator. So I'm looking for the least common multiple of 15 and 10. That's what your common denominator is going to be. So your least common denominator is your least common multiple of the two denominators, 15 and 10. You can do this a couple of ways. You can do the prime factors of 15 and the prime factors of 10 and then find it that way. I personally think with these sorts of numbers that aren't really big like this, just easier to go, well, what's 15 times 2? 30. Is 10, will 10 divide into 30? Is 30 a multiple of 10? Yes. So my common denominator is going to be 30. And I think by this point you should be pretty good at that. All right, you have to change the numerators too when you change the denominators. So we're creating equivalent fractions. This first fraction, 8/15, is going to equal whatever I get here in this first fraction. Okay? What did I multiply 15 by to get to 30? 2. So if I multiply the denominator by 2, I also have to multiply the numerator by 2. And 8 times 2 is 16. Okay? What did I multiply 10 by to get to 30? 3. So what you're seeing is whatever you multiply the denominator by to get your new denominator, you must also multiply the numerator by that same factor. Okay? Keep that in mind in a minute when we move into algebraic expressions, because that's what we're about to do. We're going to do this with algebraic expressions instead of with numbers. All right, so 10 times 3 is 30. 3 times 3 is 9. And then we can use our rule that we just wrote at the top of this page, which was keep the denominator, and 16 plus 9 is 20. I'm sorry? Oh, yes. But is that right? 25? Yes. And then we're going to reduce the fraction to 5 goes into both of them, 5, 6. Very good, Amber. Thank you. Okay. So we'll start with one that hopefully won't stretch our brains too much. 5 over 11m plus 3 over m to the 4th. So we need them to have a common denominator. In order for the denominator to be the common denominator between these two, it has to be a multiple of both of these numbers, okay, or both of these expressions. So I can't ignore the fact that this one has an 11 and this one doesn't. It has to be a multiple of it. Just like I only needed to multiply this one by 2 to get to 30, and I had to multiply this one by 3 to get to 30. You're not going to necessarily multiply, you're not absolutely going to multiply by the same thing in both denominators, but you will within the fraction. So if I have an 11 sitting here, then I am going to have a factor of 11 in my denominator, because this 11 has to be a multiple, has to divide into this one, or this one over here has to be a multiple of this one. So 11 times 1 is 11, so that works. And this one was a 1, so that 11 is a multiple of 1, so I'm good with that. Now, how many m's do I have here? 1. How many do I have here? Whatever I put here must be a multiple of both of these. So I can't just put an m here, because m to the 4th times nothing makes m. Okay? I'm going to pick the biggest one. Does that make sense? So if I've got m to the 1st and m to the 4th, then you need all 4 of them in your denominator. You pick the most factors of each, the largest amount of each factor. Okay, so this was an 11 to the first. There were no 11s over here, so I had to have an 11. I didn't say it right, so you don't want to write it down. Let me just explain it. That might be better. You have an 11 here, but no 11s over here, so you have to use the 11. So it was an 11 to the first and no 11s, so I used an 11 to the first power. I have an m to the first and an m to the fourth, so I have to use the m to the fourth power. So I have factors of m. I have to choose the largest amount of them. Okay? All right, so now we're going to change colors and ask ourselves, what did we multiply 11m by to get 11m to the fourth? How many m's? Not 4, 3. Because there's already 1 here, so you're going to multiply it by 3 more. So it'll be times m to the third. Does that make m to the fourth? Is m times m to the third m to the fourth? How many m's would you have? m times m to the third. Doesn't that mean m times m times m times m? Which is m to the what? Fourth. So a minute ago when I said we were dividing and we subtracted the powers, guess what you do here? You add them. 1 plus 3 makes 4. Okay? What did I multiply m to the fourth by to get this 11m to the fourth? 11. So you're going to put times 11, and whatever you do to the bottom, you have to do to the top. So in this numerator, so I'm creating an equivalent fraction to 5 over 11m. I would have 5 times m to the third, just 5m to the third. And here I have 3 times 11, which is 33. So I now can add my numerators together. 5m to the third plus 33. Whoa. Over 11m to the fourth. You cannot simplify that at all. So that's the answer. All right, I'm going to give you one to do that's very similar to this one. 3 over 5k to the third plus 2 over k to the seventh. All right, let's see if we can tackle this one. Move this little thing out of the way. What is the common denominator? 5k to the seventh. Okay. What did you multiply 5k to the third by to get to k to the seventh? K to the fourth. So if you multiply this times k to the fourth, then you have to multiply this times k to the fourth. So that's going to give you 3k to the fourth. What did I multiply k to the seventh by to get to 5k to the seventh? Just 5. So 5 times that, and then I just like to show it so I don't forget it. If you get this, you probably aren't going to be showing this little step right here. But 5 times 2 is 10. Now remember, y'all, one way to check yourself in your mind is to see if this will reduce and get you back where you started. That's how you check yourself. Okay, so k to the fourth and k to the seventh, yes, that would leave me with k to the third on top, and I'd be right back where I started. 10 over 5 reduces with a 2 up here, and I'd be right back where I started, wouldn't I? So that's how you know you created an equivalent fraction. Okay, and then put it over one denominator, 3k to the fourth plus 10. You can't really add those together. You can just write them as an addition expression. Now, I personally think monomial denominators are harder to see than polynomial denominators, because when you get those polynomial denominators factored, it's just so easy to see the individual factors because they don't usually have any that are embedded in the other one like that. Like this k to the third is embedded into this k to the seventh, so it just makes it a little bit easier, I think, to see when you factor them. But I'll show you what I'm talking about. Here we go. If I can find the one I was going for. Oh, I spoke too soon. They wanted us to do one with just numbers first. So I'll do this first, and then we'll go into the polynomial denominators. Okay, so 6x minus 5 over 3 minus 3x minus 2 over 7. Common denominator would be what? 21. Okay, so what did you multiply 3 by to get to 21? 7. So you have to multiply this times 7. You're going to have to distribute it, so you'll have to be careful with that. And then you multiply the 7 times the 3, so you're going to multiply this times 3. That's parentheses right there. Okay, so you're going to be left with 42x minus 35, and then 9x minus 6. Now again, this is a subtraction problem, so you're going to have to distribute the subtraction sign to everything that's behind it. In the numerator, you don't touch the denominator. You got them to be the same. So this is all over 21. So it will be 42x minus 35 minus 9x, what? Very good, plus 6. And then we'll just get our like terms together. 42x minus 9x is 33x. And negative 35 and positive 6 make negative 29 over 21. I hope that's right. Y'all check me. Okay. All right, so let's move into some that have polynomial denominators. 5 over y plus 3 plus y squared plus y plus 24 over y squared minus 9. So we have to get common denominators before you can do it with polynomial denominators. So polynomial is just many terms being added together or subtracted, any number of them. So this is a 2 terms, that's a binomial, this is a binomial also. Before you can do this, you have to factor whatever can factor. This cannot factor, but this one can. And what you're hoping for is to see maybe that they might have some in common already, which will make things a little bit easier on us. So y squared minus 9 factors into what? That's right, y plus 3 times y minus 3, because it's a difference of 2 squares. Okay. We do not need to factor the numerator until the end, if it will factor, okay? Because right now we're just trying to be able to add all this stuff together, right? So we don't want to factor it, because if you factor it, you can't add it because it's got parentheses around it and it's written as a product. Okay, so you want to leave the numerator alone right now. We're just going to change the denominator. This one has a y plus 3 one time, correct? This one has a y plus 3 one time. So I definitely am going to need a y plus 3 one time in my denominator. There's nothing else over here, but this one has a y minus 3. In order for my new denominator to be a multiple of this denominator, I have to have all the factors of it in there. So I'm going to need a y minus 3. And then you ask yourself, what did you multiply this denominator by to get this new one? I have y plus 3, and here I have y plus 3 times y minus 3. So what have I multiplied this by to get this one? Y minus 3. So you're going to put it times y minus 3, top and bottom. Did I multiply this one by anything? The second one. Aren't they exactly the same? So I won't be changing my numerator, will I? This one is going to stay the same. So you can just rewrite y squared plus y plus 24. And here we can go ahead and multiply 5y minus 15. All over one denominator of y plus 3 times y minus 3. It's adding, so I don't have to do any funky distribution of a negative sign, so that's good. I can just add my like terms together. You want to write your answer in your numerator in descending order of y. So you want it to go from the highest power of y down to the lowest power of y. So I don't see any y squares, so I'm going to go ahead and put that there. I have a 5y and a 1y, both positive, so that adds to be 6y. At positive 6y, so you put plus 6y. And then I have a negative 15 and a positive 24, so that adds to be plus 9. Now you have to check and see if this will factor. And if any of their factors of this one will cancel with any of these down here. Okay? So will this factor? Are there factors of 9 that add to be 6? What are they? So it's going to factor into y plus 3 times y plus 3, which is the same thing as y plus 3 to the second power, right? Okay, so I could write it like that if I wanted to. Y plus 3, y minus 3. So these are going to cancel. And your final answer is y plus 3 over y minus 3. Again, where do students mess up here? They don't want to stop here. This is the answer. They want to mark out the y's and tell me the answer is negative 1. But you can't do that, right? Because this y has a plus 3 and this y is a minus 3. Let's say y was 4. 4 plus 3 is 7. 4 minus 3 is 1. So the answer to that would be 7. 7 over 1. That's not negative 1. So anytime you're tempted to do that, just say, well, what if the variable was this? Would that equal what I'm thinking that it would equal? And it won't. Okay, we're going to do one more problem. No, we're probably going to do 2 more problems. 2 more. I'm going to let you try this one on your own. See if you can handle it. And if not, just pay attention when I work it and try to make those adjustments.